Let's take a look at the derivative of natural log of x. So we've just talked about how natural log of x is equal to the definite integral from 1 to x of 1 over t dt. If we want to take the derivative of that, we can do the derivative of both sides. And derivative of natural log of x is what we're trying to figure out here, so we're going to keep it like that. And we can actually take the derivative of this. This is the second fundamental theorem of calculus we learned a while back. If we take the derivative of a definite integral from a constant to x, all it ends up being is taking this x and plugging it into this function. So we end up with a derivative of natural log of x, which is equal to 1 over x. So looking back at what we had up here, if we do the antiderivative of 1 over x, actually we're going to get natural log of x plus c, because the derivative of natural log of x is 1 over x. We'll do more with the antiderivative a little bit later. Today we're going to focus more on the derivative. Now let's take a look at the graphs. We've got y equals natural log of x right here, and y equals 1 over x right over here. Remember, we just said that 1 over x is the derivative of natural log of x. So we're talking about this being the slope of this function at any given point. As we look at natural log of x, over here between 0 and 1, we have a slope that's steep, and it's starting to get less steep. So as we go throughout the function, the slope of the graph gets less and less. If we look at its derivative, we have a very large y value over here, close to 0, and then those y values get less and less as we keep going to the right. So it kind of matches up there. All right, one last part here before we try some examples. Here we have it in general in terms of u, because a lot of times we're going to be using chain rule for problems like this. So if we take the derivative of natural log of u, where u would be something in terms of x, then we get 1 over u times the derivative of u with respect to x. So it's just chain rule within natural log derivative. Down here it has natural log of absolute value of u. This is going to be treated the same way, 1 over u times du dx. Absolute value is in there because we can't take natural logs of negative numbers, so this ensures that we're taking a natural log of a positive value. So that doesn't change anything up. The derivative still stays the same.